Hi Shana, in the last class we were not able to complete the class, complete the question number 4. So I thought of making a video on this. So the question number 4, a Bowman string is a string of letters that satisfies the following two conditions. Each letter in a string is A, B, C, D, E. No two adjacent letters in the string are the same. So these two conditions makes the Bowman string. And also they gave us an example. A, E, C, D, B, D, C, E, C are Bowman strings of length 4 and length 5 respectively. So this is for length 4 and this is for length 5. And also you just check whether these two examples satisfies these two conditions or not. So A, E, C, D, yes, all these letters are in the string, from the string. And if you look at this, you could see repetition of C, but it is not adjacent, right? You can see E in between double C, right? So this string can be called as Bowman strings. And also A, B, B, C, B, A, triple E are not Bowman strings because you could see two adjacent letters and here you could see three adjacent letters. So this example fails to meet the Bowman condition. I hope you understand the conditions required for the Bowman string. So let's go to the subdivisions. In the subdivision A, they are asking us to find how many Bowman strings of length 5 are there in which the first letter and the last letter are both A. So that is the question. We'll go to the solution. I'll just show some images. I've solved this previously. I'll just share those images after reading these lines. For each Bowman string of length 5, in which the first and last letters are both A, the second and fourth letters are not A. I'll show you. Research. Yeah. So as I said, the first letter and the last letter for the length 5, A, A. And also, second and fourth cannot be A according to the Bowman condition, because if I put A over here and here, then I do have two adjacent alphabets here. So that will not satisfy the Bowman condition. So I'm not allowed to include A in the place of second, in the place of 2 and 4. I hope you are able to follow. So this one you keep in mind. That means you could fill A in the third place, right? You could fill A in the third place. Second position and fourth position, we cannot fill A, but in the third position, we can fill A. I hope you are able to follow this. So we'll take the third letter as A as the case one. So A, first place, second place is unknown, third place is going to be A, fourth place is unknown, fifth place is going to be A. So for the second letter and fourth letter, we do have 4 choices out of 5, right? In the first condition itself, they said we can use A, B, C, D, E, but we are not allowed to use A in the second position or the fourth position. So we do have 4 choices here. You can fill B, C, D, or E. Same goes with the fourth place as well. You can fill B, C, D, or E, right? So totally you do have 4 into 4 choices, which means in the case 1, you're going to have 16 such Bowman strings. So that is for the case 1. And again, we can go back to the case 1 and you can do a small change in it, uh, because in the third position we have chosen A, but you can also choose B, C, D, or E as well, right? You can choose like any one letter from all these 5 options, right? So we'll assume that situation as the case 2. So in the case 2, the third letter is not A. So I'm going to assume the unknown value is X here, which means the third letter is B, C, D, E. Because for A, we have already concluded the solution. So you don't have to include A again here. So we can find what if the X is B, C, D, or E, which means you do have 4 choices for the third letter. Again, um, you are going to fill B or C or D or E. We are not done with the second position and fourth position yet for this case. So you are going to fill the letter here, but the number of choices is going to be different. I'll tell you how. Assume you are filling you are filling B in the place, B in the third place. For second and third, for second and fourth position, we usually have these 4 choices. But if you fill B in the third position, you are not allowed to choose B for second position or fourth position, right? Which means you're having only 3 options because you're not allowed to place adjacent, the same letters in the adjacent position, right? So again, what if you choose D in the third position? So if you choose D in the third position, again you're not supposed to include D in the second position or the fourth position, right? So for the second position and third position, you're going to have only 3 choices, isn't it? Anyway, you're going to keep one letter in the X position. If you choose that, you're not allowed to choose the same letter for the second position or the fourth position. So it's going to be 3 choices for the second position and 3 choices for the fourth position, which means fourth letter. Okay, so it's 3 into 3. For the X, we know we have 4 choices. So if you multiply all together, you're going to have the result as 36, which means 36 such Bowman strings. So for the length 5, which the first letter and last letters are both A, is going to be 52. 16 plus 36 will give you 52. We are just adding the case 1 and case 2 here. I hope you are able to follow this. We'll go to the next question. In the next question, they're asking us to determine the number of Bowman strings of length 6 that contain more than one B. More than one B. I think for the B, you can refer the solution 2. That was easy actually. Solution 2 was easy. Yeah. So they're saying that the Bowman string of length 6 cannot contain more than 3 Bs. I'll tell you how. I'll show you the image. Image. Yes. Okay, in the solution, in the very first statement, they're saying that string of length 6 cannot contain more than 3 bees. For example, um, if you have more than 3 bees, it will be like we do have only 5 choices, right? A, B, C, D, E. And also they're saying that you need to make length 6 now. Okay, you're going to make length 6 of a string now. So which means you're going to choose one letter from these 5 choices again, right? For making the 6th position. And if you choose more than 3B, what happen? You will have A, B, C, B, B, D. Or else, if you shuffle them, maybe you will have B, A, C, D, B, B. See, for choosing exact 3B itself, we do face a problem. In the second condition, they said you're not allowed to put the same letter in the adjacent places, isn't it? So from this we can say string of length 6 cannot contain more than 3 bees. Okay. So what happens if you choose 2 bees exactly? You're going to have like A, B, C, D, E. So you can see length 6 from this string, but you do have 1B and 2B. But still, this holds the Bowman string condition. You can call that one as the Bowman string. Maybe you can rearrange the position. You can have like A, C, B, D, B, E. Again, there is no adjacent B's. Yes, so you can call this one as the Bowman string. So you can make a number of choices out of it. What if you have exact 3 B's? So for exact 3 B's also you can have Bowman string like A, B, C, B, D, B, right? I just put them in the alternative place, but still this satisfies the Bowman string condition. Okay. And also you can switch their position like B, A, B, C, B, vice versa. Still it satisfies the Bowman string. I hope you are able to follow. We'll go back to the solution again. Hmm, where is the solution? Yeah. So a Bowman string of length 6 cannot contain more than 3 beats. That I told you, and there also they have mentioned, confirm for yourself why this is true before proceeding. Because like that fails the second condition. We may determine the number of Bowman string of length 6 that contain more than 1B directly. For more than 1B directly only, I showed you the example for 2Bs and 3Bs. Okay. So again, we are drawing a case here. For case 1, we want to choose exactly 3Bs. Look at the position. B and the adjacent position is empty, and B, the next position is empty, B and empty. So this is for the exactly 3Bs. We can also have like B empty, B empty, empty, B. B empty, empty, B empty, B. You know, I hope you are able to follow it. I think the first one and the last one is supposed to pretty much be same. It's just vice versa. Um, so you do have these options, and for the second letter, over here, here, here. I mean, not here. So let's choose this one. Let's choose the first string and discuss. I'll show you in the image. Wait. I have written the solution separately. Yeah. So for exactly 3Bs, I have made the string like this. So I'm assuming this one is the first string. B blank, B blank, B blank. Okay. Um, so in the second letter, you will have 4 choices. You can choose A, C, D, E, right? We do have 4 choices. Similarly, for the fourth letter, still you have 4 choices. You can put A, C, D, or E. And that goes same with the sixth letter as well. Same, we're going to have 4 choices, A, C, D, E. which means 4 into 4 into 4, which will give you 64. I hope you are able to follow. 64 for the first string. Look at the last string, the fourth cell. It's just pretty much the same, but the position is different. For the first letter, third letter, and fifth letter, you can have the same four choices as A, C, D, E. It's just identical, right? The string 1 and string 4 are identical to each other. So for the string 1 also you're going to get 64 Bowman string. For the string 4 also you're going to get 64 Bowman string. And now we are going to solve the string 2 and string 3. Okay. Now, the next string. Yeah. For the second string, you have B empty, B empty, empty, B, which means we have to worry about the second, fourth, and fifth position. Okay. Again, in the second letter, for the fourth letter, you do have four choices: A, C, D, E. Okay, for the second letter and fourth letter, you can use A, C, D, E. But for the fifth letter, you're not allowed to use A, C. If you are using um, A for the fourth position, you are not allowed to use the same A for the fifth position, right? In case you are using C for this, you are not allowed to use the same C over the fifth position, which means we are going to drop one choice from this, right? Just to avoid the repetition. So you're going to have three choices for the fifth letter. I hope you are able to follow, right? For the second position, you do have four choices. For the fourth position, you do have four choices. For the fifth letter, we do have restriction that you cannot use the same letter as the fourth place. I hope you are able to follow this. The next one. So, if you look at the choices, you have four choices in the second place, four choices in the fourth place, and three choices in the fifth place. So it's going to be 4 into 4 into 3, 48 choices. Okay. And also, if you look at the second string and the fourth string, they are merely symmetric. They are identical only. Okay. From that, we can conclude for the second one and the third one, you're going to have same Bowman string choices, 48 and 48. Very simple. So let's go back to the solution again. Where is the PDF? Solution. Okay. So 48 into 48. So this is for the second and third, and this one is for the first and fourth. So if you add all them together, it's 64, 64, 48, and 48, you're going to get the answer as 224. So 224 Bowman strings with exactly 3 beats. So you're going to apply the same logic for the two B's as well. For the two B's, you're having, like B, this is empty, which means you're going to have four choices for the second position, A, C, D, E. For the second letter, you're having four choices. And for the fourth letter, fifth letter, and sixth letter, um, okay, for the fourth letter also you can use A, C, D, E. For example, I'll write this again. B, B, B. If I'm using A out of these four choices, I can use the A again here because we're not able to see any repetition. I mean, like, there is no any, mm, we don't have to bother about the adjacent position here, right? So you do have four choices in the second letter and four choices in the fourth letter as well. But in the fifth one, you're not allowed to choose A, right? Which means you're only going to use C, D, E. Uh, and you should not use B over here because already the B's are restricted. We are going for the string which has exactly two B's here. So forget about the B. Here we are only dealing with A, C, D, E. So in the third position, you are not allowed to use A again. So you're going to have three choices, right? C, D, E. But I mean, this is fifth position, right? In the fifth position, you will have three choices. But in the sixth position, if you are using C, D, E, you're not use the same letter in the sixth position, but you can include A here, right? You can include A here. Assume you are using C in the fifth position. You're not to use the same C in the sixth position, but you can use D, E, or A, right? So you are having three choices in the fifth position and three choices in the sixth position, which means 4, 4, 3, 3. So you're having like 4 square into 3 square, which would give you the result as 144. I hope you're able to follow the logic. So you just follow the same thing for the rest of the string as well. Okay. So if you apply the same condition, it's saying that, and also you can find some symmetric structure as well. Okay. If you look at this, it's saying that like empty empty b empty b empty is symmetric to empty b empty b empty empty, which means it's just a mirror image of this. You just go like from left to right, like here it just goes like right to left, just the mirror image of this. So you can call them as symmetric. So you are going to use the same results for the this one as well, whatever you're getting obtaining for this one. Okay. So if you're getting the result as 192 for this is also going to be 192. So be careful with the symmetric one, I mean the similarity structures. Okay, I hope you're able to follow the logic. So you are just, at last, you're just going to add everything together and you'll be getting the answer as 1548 for the exact 2Bs. At last, we are going to add the exact 2B results with the exact 3B results. And you cannot go more than 3Bs. I told you why, because it failed to meet the Bowman string condition. Okay. So we do have like 224 and 1548, which gives you 1772 Bowman strings of length 6 that contain more than 1B. So for more than 1B, you are choosing exactly 2Bs and exactly 3Bs. Okay, that's it. I think maybe this C we can discuss in the class. Please go through this whenever time allows you. Thank you.